Hello friends, warm welcome to my new video. Today I am presenting my new homemade CNC writing machine, and this is a very cheap UI type writing machine. Most of the parts I am just arranged locally or from very old electronics goods, and use a very low cost stepper motor to have a good writing machine. So first of all, I want to show you just show you how my writing machine works. You see, this is my writing machine, and it is work very fine. I'm actually drawing a image of Swami Vivekananda. If you are from India, you know about Swamiji, and if you are from abroad, this is our national hero. And you see, my writing machine actually very precisely draw the image of Swamiji. I'm just fast forward it because it takes time to write down. It is not very fast. Uh, so this is the project. So if you are the student from plus two or BSc level, I'm sure that you are enjoying your summer holiday. So this is the best project for you. Uh, I will discuss the whole setup of this writing machine, starting from the hardware part to software part, and some error which you generally face, and I will try to solve this error or fix this error so that you can easily make your own writing machine. So basically, writing machine is simply working like a hand. Okay. As you know, to write something, we need three motion which are mutually perpendicular to each other. Okay. So we need a x motion and y motion and z motion. So from the electronics perspective, this type of motion generally controlled by obviously by some motor. But normal motors cannot perform this type of job because if you want to have a certain coordinate like x comma y comma z, so your tip of the pen move very precisely to this point to another point. To do this, we need actually a very precise motor which actually move a very small step for each pulse, and this type of motor are called the stepper motor. Okay. And so we need a stepper motor. To control the stepper motor, we need a microprocessor type where we can program and also the driver. So I will first discuss about the motor. There are two type of motor. There is stepper motor are generally two type. Most of stepper motor. One is called unipolar stepper motor. Okay, unipolar, and another is called the bipolar. So motor are generally two type. One is unipolar and one is bipolar. Okay, so see, this is a unipolar stepper motor. This is 28 PYJ48 stepper motor, and this is a NEMA 17 stepper motor. Okay, and unipolar motor in generally this coil of the unipolar motor are generally center tap. Okay, so we have the five wire coming out from this motor, and for this NEMA motor, we have the coil which are not center tap. So we have four wire coming out from this one. Okay, so these are the two motor. But if you need a better torque and a bigger arrangement, a bigger CNC machine, so you go for the NEMA 17. And if you want to have a small this type of CNC writing machine, you can go for this type of motor, unipolar motor, because it is very cheap. The both two pair you can get around 250 to 300 rupees. So this is very cheap. Okay, and very easy to use. And to control the 28 BYJ48 stepper motor, you need this type of driver. This is ULN 2003 driver. And to control this NEMA motor, we need this type of CNC seal. Okay, and these are the drivers. This is a 3988 something, this type of motor. I'm not using this type of motor here. And this is a very unique thing. It is called Arduino Uno. and this Arduino Uno, actually the board which can do program, small program can be done with this microcontroller. And here in this CNC machine, I'm using Arduino Nano, a small version of it, and it is also very cheap. You can easily get it around 400 or something like that. So each CNC machine is generally consists of two part. One is called the hardware part. So hardware part is very important. First of all, you need Arduino. Second thing, you need a driver. Third thing is a stepper motor. Fourth thing, you need some CNC rod and plus belt to control the XY motion. But CNC rod and belt, instead of belt, you see I am using a simple rope here because it gives you the more precise control. Here this type of string, it gives you the more precise control because CNC belts are pretty heavy, and it is very difficult to control. So this is why I'm replacing the CNC belt with the small string. It is very useful here. Okay, and CNC rod you can get it from old printer or cartridge of the printer. You can break it and you will get the CNC type of rod. And this is very useful to make this type of things. You need a certain PVC pipe, which I am using here. So the construction you can get from any good YouTube video. There are the several uh, website which actually design some CNC construction. So these are the requirements. You need also some jumper wire glue or something, hot glue or something like that. And for the base, you can use the plywood or any acrylic board or something like that. So this is the hardware part. But the software part is very important here. Okay, and this actually creates various error, and you need to fix this error. So I just do step by step. Okay. So first of all, I will discuss about Arduino. So first of all, I will discuss about Arduino, and for Arduino, you need to install Arduino IDE. Okay. So you just go the Google Chrome, you search for Arduino IDE, this type of interface will open. Then you can download according to your requirement. Like if you use Windows 10 or newer, then you just download it and install it. I will recommend to install Arduino 2 point. Here I am using the Arduino of 1.8.19. It's very useful here. So once you install it, it will open like this. Then you connect your Arduino. And there is a connection cable here. After connecting, you just go for tools, and in tool you will see the board. So you choose the appropriate board. Here I am using Arduino Uno. If you use Arduino Nano, then you choose Arduino Nano. I'm actually using Arduino Nano, so I am choose here. And once you connect it, you will get the popper port. You just connect your COM port here. Choose the popper COM port. Then you need to install a library here. Okay, because Arduino, when control the CNC stepper, you it need a certain library, and this library is called GRBL library, GRBL. Okay, there are another way of controlling it, but this is very useful. The GRBL library. So you first install the GRBL library. Okay, then you upload the GRBL library to Arduino. For this, you again go for uh, you can go to the your search engine. But first of all, I need to discuss about GRBL library. There are different GRBL library. Like here I am using two 28 BYJ 48 stepper. Okay, two. And another is servo, okay, for pen up down motion. These are for the X plus Y motion, and this is the Z motion. So for this, we need to upload the appropriate GRBL library. This is very important. Okay, so go for the search engine and to search 28 BYJ48 plus servo GRBL. So this type of library will open. You see, you scroll down here, you will find this is the thing we actually. So just click here. We need this library because we are using two 28 BYJ48 servo and one servo for the Z motion. So you go for code, you find the zip library here, you just download it, and then after you download it, you will find that this is the zip library. You just unzip it. Here I am unzipping it. You will see there are GRBL library. So you just copy it and then go to the Arduino library where you can paste it. After pasting the GRBL to Arduino library, then you go here and click file, then example, and if you click example, you will see there is a GRBL library here. So click here, new window will open, and this is the GRBL. Without changing anything, you just upload it, first compile and then upload it to Arduino. So again, I am saying repeat it, like you first actually download the GL library, then unzip the GL library, then copy the GRBL to the Arduino library, and then open the GRBL and upload it to Arduino. When you try to upload the Arduino, you may face certain difficulties in upload. To how to solve this, I will show the way you can solve it. So this is the GRBL. You open it and go here, stepper. Okay. Open it in your notepad. Now scroll down. Okay. Here you can find this thing. Okay. You just remove this two slash and then go here and save it and then try to install if you find any difficulty. Okay. Once you do this, you will see your GRBL library easily upload to the Arduino. So first step of software is done. Okay. So we install Arduino, then we upload GRBL to Arduino. Then what? Then you need to draw with your CNC machine. But to do this, you need to vectorize your image. That means, suppose say this is a circle, and this circle need to be vectorized because this is a image, and you need to convert it image to path. That means your image is converted to certain coordinates. Okay, depending on the part. X, Y, and Z coordinate. And when you fed this coordinate to your CNC machine, it will draw according to your instruction. So you need another software, and to do this, I am actually using Inkscape software. This is a very popular one, Inkscape software. Just open it. It takes time. Once it open, I will show you how to vectorize your image. Okay. Okay, the page will open. Now you change your object property. You can find the object property here. If this window is not showing, you just go for the document property, then this pop-up will open, and here you can actually change the size of the plotting area according to our CNC. I am just using 50 centimeter by 50 centimeter, so as the unit is in millimeter, so I am just using 50 by 50, so it has become a small rectangle. Or these are drawing area actually. Okay, so first of all we just enhance it properly. Now you can draw anything. I am just showing a spiral here. So I'm just put a spiral here. You just select it. You can make it bigger according to your requirement. So this is our spiral. Okay. I just select it, then go from object to path, then extension, and in extension you can use the 4xi draw tools. Now go for the generate pen servo G code tool. Click here. You will find this window will open, and there is nothing to be changed here. If you want to change the travel speed, then you can adjust it according to your requirement. And this is the pen up down command M03 or M05. You can use it. So I'm just click apply here. Okay. Once you apply, then it takes some time, and it will convert your image to certain coordinate, and CNC machine will follow the coordinate to draw the spiral. Okay, so as you see, the actually the thing is working, and it actually writes a code which is called the G code. Then close, you will see this is our 00 position, that means the x0, y0, and z0 position, and after that the pen will move. Pen will move, and the figure will draw. Okay, so if I am showing the what is G code, this is the G code is actually, as you see, this is the G code, this is the XYZ command. As you see, it start from here, and G1 X 23.8 Y 19.8 is the first initial coordinate. From 002 first go here, and then pen comes down, and then start again from this coordinate, and after the executing whole coordinate path, it will come again here from x equal to 0 and y equal to 0. So this is our G code. Okay, so we first install Arduino IDE, then GRBL library, then upload the GRBL library to Arduino. Now we are trying to draw image. To do this, we actually need software which is called Inkspace, and to have Popper extension, the 4xi extension, you can actually find it from website, and then you can actually copy this extension to our library of Inkspace, where you find the share an extension file where you just paste the extension, you will convert the image to the 4xi G code tool. After that, you need another software which is called the G code sender. So I am using here is Universal G code sender, UGS. It's a very useful software, and with the help of UGS, you can actually control the CNC machine. Okay, so I will also, you can download it from the website USG, or you can write down Universal G code sender. So this is a GitHub page, and you can install it from there, Universal G code sender. And once you install it and then unzip it, and you can have this type of file. You go there, you will open the bin file. From bin file, you have the Universal G code platform. So it will take some time, and then it will open, and then connect your CNC machine to your port. And once you click it, it will automatically connect to the Universal G code sender. And once you connect the Universal G code sender, then you can actually adjust your XYZ position according to your requirement, and then upload your G code file. I will show you how to upload it, and then click run. This is the interface of Universal G code sender. This is the first of all, you choose the GRBL library, then choose the Popper port, then choose the part rate 115200. Then click here. Once you click it, then it will connect. Then you will find this type of interface. This is the toolbox, this is the macros, this is jog controller. Jog controller, actually, if you click the X, Y, Z, then you will find X and Y, not Z, because Z is not present here. If you use three stepper motor, then you can use the X, Y, Z. But if you use servo, then you need to put a command here. This is the command line here, and here you can write M03 S20 or 30. If you want to move the 20-degree, then servo angle, servo 20-degree, then you can write M03 S20. If you move it to the again the zero position, then you can have M05. Then it comes back to the zero position. So depending on that, you can actually adjust your servo motion. So once you connect it, and you can check your XYZ motion from here. Now just click here, and open your G code command. Say this is the our my G code. Once you clicked it, it will open here, and you will see this spiral which we have drawn earlier. Okay. If you clicked it, this spindle actually move according to this direction, and it will automatically actually draw your desired image. Okay. So these are the whole thing I am discussing. So if you have any question, so please write your query in my comment section. I will help you how to design or how to manage the software. So this is a very big video. So thank you for your patience, and please subscribe me to make new exciting video. Okay, please subscribe me and comment.